In this lecture, I am going to talk about binary search. Binary search is considered to be much faster than the linear search. There is a reason behind it. I would explain it in a bit, but before that, let me tell you that you should always remember that binary search is applicable only on sorted arrays. Only on sorted arrays. Either your array should be in ascending order or it should be in descending order. Like in this example, as you can see, this is an array with the name AR and its elements are sorted in ascending order, right? So what I will be doing is I will be starting searching from the middle element. If the element happens to be smaller than this middle element, then I will be looking out for the element only from the left subarray, this one. And if the element to be found happens to be bigger than this middle element, my search would be restricted only to the right part, that is right subarray. So you can easily judge that this search is pretty fast, right? Because we would be breaking down our array, our area of search each time when we are trying to search it from the middle element. Okay, so let's assume that I want to search an element with the value 100. So value of val which is to be searched is suppose 100. Now what I will do is I will be taking three variables. This is my dry test. LFT is for leftmost subscript, RT is for rightmost subscript, and MD is for the middle subscript. As you can see, my subscript starts from 1 because I am using it for algorithm, and we have total number of 10 elements, so last subscript would be of course 10. So LFT is 1, leftmost subscript, RT that is rightmost subscript is 10, right? So what will be MD? LFT plus RT divided by 2, simple. And we are interested only in getting the integer part because you know subscripts are never in decimals. That means 1.5, 6.2 or something. There are no such subscripts. They are always in the form of integers. So 1 plus 10 divided by 2, that will give you the integer value 5. Okay. Now to start with, 100 is the value to be searched. I will be comparing it with the middle element, that is R5. You can clearly see that value to be searched 100 is bigger than the middle value. Middle value is 70, that is R5. See, value of MD was 5. So now it is but natural because array is in ascending order. There is no chance, there is no possibility that this value can be found on the right side of this middle element. Now the possibility lies only on the right side of the array, that is right sub array. So I would be restricting my search only on the right sub array. So what should I do is I would be changing the value of my LFT. So LFT will become MD plus 1. What is MD? MD is 5. So LFT will become 6. Value of RT will not undergo any change. Right. So now LFT is 6, that is this is leftmost subscript now instead of 1, and rightmost subscript is 10. See, 6 and 10. Now find the middle element within this subarray. So 6 plus 10, 16 divided by 2, it will come out to be naturally 8. So now I will compare this value 100 with R8. R8 is my middle element of this subarray. So I will compare 100 with R8 value, that is 90. Again, the value to be searched happens to be bigger than the middle value. So again what I will be doing is I will be changing the value of leftmost subscript, that is LFT, and that will become MD plus 1. What is the current value of MD? 8. Now LFT will become 9 and RT will remain same, that is 10, right? So again I will be finding the middle element. So now my area of search is restricted to this only, from R9 to R10. See how efficient is this logic. So middle element would be 9 plus 10, that is 19 divided by 2. So in integer, naturally we'll be finding the value of MD as 9. So middle is MD is 9. Okay, again I will start comparing. I will compare val with R9. Yes, the comparison is, the matching is successful. So we will say that we were able to find the element. Okay. To make this understanding concrete, let me give you another example whereby the element to be searched happens to be on the left side of the array. Okay, this is it, right? Now suppose I want to find value 10 from this array. Again, this is my dry test. LFT is, that is leftmost is 1, rightmost subscript is 10. Of course, MD will be LFT plus RT divided by 2. In integer it will be 5. Okay, so my comparison, I would be comparing this value val with the middle element R5. Value of MD is 5, so R5 happens to be the middle element. Of course, value 10 happens to be smaller than this middle element. So see clearly now the chance, the possibility of finding this element 10 lies only on the left side of this array. So this is left sub array. So our area of search has been restricted only to this part. So what should I do is, I should change, this time over I should change the value of my RT. Now value of RT instead of 10, now it should be 4. So how I will be getting it? I will be writing RT is equal to MD minus 1. So what is MD? 5. So RT will become 4, right? Again, the area of search has been restricted to this particular range of elements R1 through to R4. So 1 plus 4 divided by 2 will give you the new value of MD. So 1 plus 4, 5 divided by 2. Of course, in integer it will be 2. Again, I will make the comparison of val with R2 because R2 is now the middle element of this sub array. Again, the value of val, that is 10, happens to be smaller than the middle element, that is R2. So again, the chance of finding it lies only on the left sub array, right? So what I will be doing is, I will be changing the value of my RT, that will be MD minus 1. So it will become 1. What is the current value of LFT? It is stagnant at 1. So I will be finding the middle element MD. So LFT plus RT, 1 plus 1, 2 divided by 2, it will give you the value of MD as 1. Again, I will try to compare the value of val with the middle element. Now in this case, middle element is R1. So the matching will take place and we will say that search was successful.